We are given this differential equation y prime prime plus 3 over x y prime prime minus 6 over x equals to 0. Multiplying both sides by x cubed, we obtain this expression. So our goal here first is to find the complementary equation. So we equate this to 0 and we will find the value of this m that will satisfy this differential equation. So differentiating this, we obtain this m times x to the m minus 1. After we differentiate this, we differentiate again because we have this y prime prime and y triple prime. So differentiating this again, we have this and simplified. After we differentiate this again so that we have now our triple prime or the third order derivative. So after that, we will substitute these values to this y prime here and this y double prime here for this whole equation. So notice that this thing will cancel out with this and also this one with this. So we now left with this expression, and by factoring we have this, and since this x to the m is not equal to 0, it follows that this equation will just make it 0. So by factoring it, we found out that m1 is equals to 0, m2 is equals to 1, and m3 is equals to negative 1. So we now have our complementary equation, which will be our basis to find our particular solution. So by methods of variation of parameters, we vary these constants and make it u. And our goal again is to find the values of u so that we don't have the particular solution. So we need first to differentiate this. This is our y1, which is equals to 1, and our y2 is equals to x, and our y3 is equals to x to the negative 1. This is our y3. So this 3. Then differentiating this 0 0, and this differentiating this 0, this one differentiating. So we now will be able to find the value of Wronskian. So substituting this to here, this is just like this, and this one and this one. So after that, we will evaluate this 3 by 3 matrix, and after simplifying, we found out that this is just equal to 2 to the x to the negative 3. So first thing is we need also to find the Wronskian one, in which we replace this by 0 0 and the function of x, which is equals to 6 over x from here. This is our function of x. So evaluating this 3 by 3 matrix, we will find this value, negative 12x to the negative 2. So for the Wronskian 2, we've just moved this to the between. Notice that this is just the y1, y2, y1 prime and y1 prime prime. So evaluating this 3 by 3 matrix, we find this value 6x to the negative 3. So again, we move again this to here from our basis from the Wronskian, and evaluate this 3 by 3 matrix. So we found out that this is just 6x to the negative 1. So we'll now find the value of u1, because we know that u prime 1 is equals to Wronskian 1 over Wronskian, and this is just like this, Wronskian 1 over this Wronskian. We found this u1 prime, but this is after this we need first to integrate this with respect to x, so that we find out that u1 is equals to negative 3x squared. So for u2 prime, we find this is 3. So after the integrating, we have 3x. And for u3 prime, u3 Wronskian 3 over Wronskian, we have this 3x squared, and find this x cubed. So we now have the values, so we'll be able to get the particular integral or the particular solution by substituting the value of u1 and u2 and u3. So we have this, we found out this is x squared. So we now have the general solution, which is equals to yc plus yp. Our yc is this 1. This is x to the negative 1. Constant 1 plus constant 2 x plus constant 3, then x to the negative 1 plus x squared. This is now our general solution. So we're given this initial condition that at 2 times y of 1 minus y of 2 plus 1 is equals to 0, and this 2y prime of 1 minus y prime of 2 is equals to 0, and also this. And after this, we found out that the solution that would satisfy this condition from here is this, y of x is equals to 2 plus x squared.